Hi all, today you're going to be covering topic 4 lesson, the answer keys posted on the classroom page. And then when you finish this, which most of you will in class, you can work on your blue review sheet, which I will not collect until Tuesday, but you can turn it in today to the sub if you're done. And then you'll have time to work on your test review packet. You can see that the review is going to be on Tuesday and your test is going to be next Thursday, May 4th. So without further ado, let's take a look at the topic 4 lesson. This is going to be very similar to topic 3 with the sampling distributions, except we're going to move on to two groups and looking at the difference between them. So just a quick review, statistically significant means you have a value or something more extreme that's happening less than 5% of the time. That's making it statistically significant. All right, so we have 72 students that are randomly divided into two equal sized groups. Each member of group 1 is meeting with a tutor. Group 2 is given an online subscription to a tutoring account, and they're given the same test at the end of this time. So here's the summary. This symbol here represents the sample mean. You don't need to get too caught up on this, but that symbol is the sample mean, and the symbol below it is the sample standard deviation. So this symbol x bar is the sample mean, the symbol s sub x is the sample standard deviation. So when it says calculate the mean difference in the grades, what you have to do is utilize the grade. They're telling you which order to do it, group 1 minus group 2, and explain its meaning. So group 1's mean 80.16 minus group 2's mean 83.8 equals negative 3.64. So that's the mean difference, and then explaining its meaning in context. I'll do that up here. If I could use my computer. The average test score for group 2 students is 3.64 points higher than group 1 students' average. So on average, group 2 students are scoring about 3.64 points higher than group 1. All right, that's the mean difference and explaining its meaning in context. The second part of this is now going on to say we want to figure out now, based on the simulation, they re-randomized the students' final grades 500 times. So basically, they took all the students' grades and just randomly put them into two groups of 36 and looked at the differences. And we want to know if there's a significant difference in the final grades that we saw in our experiment. So what we're going to do is look at negative 3.64 or less. So essentially, it's going to be here over. So we're going to need to sum up these two frequencies, which I'm going to go to the answer key. It'll be a little clearer here. Yeah, you're summing up those two frequencies. You can see this frequency is about 6. That's not helpful at all. Let me go back. This frequency is about 6, and this frequency is maybe about 3. They did this 900 times, so we're looking at about 9 divided by 500, which ends up being 1.8%. And then let me go back to the key. So 1.8%, so we would say there is a significant difference in the grades because that difference of negative 3.6 or less only occurs 1.8% of the time, which is less than 5. So you might not be able to read that, so let me put that here. There is a significant difference in the grades as a difference of negative 3.64 or less only occurs 1.8%, which is less than that 5%. Okay. That's the first question. Let's take a look at question number 2. So you're going to see in this lesson, you're going to have to utilize the 5% rule a lot more than we did in the previous lesson, where we had confidence intervals for almost every question. So here we have 2 classes took a test. 8 random students' test scores from each class are shown in the table below. Calculate the mean difference in the average test score. So very similar to what we did in number 1. So what we're going to have here is the average test score for the one group and the average test score for the other group. So in this case, we're looking at, they said red minus blue, so 82.7 minus 84 equals negative 1.3. And then we're just interpreting what that means in the context of the question. So the average test score for the blue class is 1.3 points higher than the red class average score. So on average, it looks like the blue class did about 1.3 points better than the red class. So now we're going to take that difference of negative 1.3 in part B, and we're going to utilize that to see if the results are significant or not. Now, they're just using a different term here. Would you support the claim that the difference found was unusual? So instead of significant, they're saying unusual. And we had a difference of negative 1.3. So what we're going to do here is take everything at negative 1.3 and below. So it looks like all of these that you're going to be summing up the frequencies. And it's a little tricky, but most of these are going to be 10, 20, 10, 10, 50, 20, 20, and then maybe that 30 that we're including. So let me show you here. Okay, this is a little clearer. You can see we are going to include that value here at negative 1.3. And then you'll notice here the frequencies I'm adding up. There's the 10, 20, 10, 10, 50, 20, 20, 30, 20 to get 190. And they said they did this 2,000 times. So essentially what we're doing is we're taking the 190 divided by 2,000, changing this into a percentage. Let's see what that is, 9.5%. Keep hitting the wrong button. So this is 9.5%. So the difference is not unusual because a difference of negative 1.3 or less occurs 9.5%, which is greater than 5%. So it's not statistically significant. It's not unusual. It's fairly common. All right, we are going to look at one last question in this video. So if you skip all the way to page 6, I believe it's on, the first multiple choice question here. Let me see if I can just get it all on one page. Yes. Okay. Gabriel performed this experiment. He wants to see if the tomato plants planted in black mulch leads to larger tomato plants than the 3 without the mulch. So he observed that the weight from the tomato plants grown in the mulch was 5 ounces more than those without the mulch. So we're looking at a difference of 5. And then what he did, he wanted to know if the difference is statistically significant. So he re-randomized the weights of all the plants and subtracted and figured out what he got just by chance alone. And now we're going to look for what's the probability of getting a difference of 5 or more just by chance. Well, you can see really quickly, this is going to be way more than 5%. So this difference of 5 or more is not unusual at all. I mean, you can see right here all the dots that lie in this grouping here. Okay, so if we take a look at the answer choices, there was no observed effect. Oops, let's skip ahead. Okay, there was an observed effect. It was 5 ounces greater, but the effect could have been just due to the chance of the random assignment. So we don't have enough evidence to say, yep, the black mulch caused the plants to be greater in weight than not. So that's why we don't have strong evidence to support the hypothesis that they're larger or that the ones without are the ones planted without mulch are larger. Well, that doesn't make any sense. The one planted without mulch were not larger, so that doesn't make any sense. So the observed effect just could be due to chance here. So what you're going to need to do is you're going to need to go through the rest of these pages and finish up this lesson, and then come back and watch the second video in which I will go over those questions.